Hello, my presentation today will be on how autistic traits are correlated with sensory preferences. A little introduction first. My name is Eunjae Jeon. I'm a junior at Lake Washington High School. My mentor is Aya Caballero, a psychology PhD student at NYU, and we investigated the correlation between sensory symptoms and autistic traits together. So what is autism? Autism refers to autism spectrum disorder, or ASD. It is a neurodevelopmental disorder that primarily affects social communication. So even though I'll be focusing on sensory symptoms here, ASD is a lot more than that. It means difficulty with interpersonal relationships, nonverbal cues like eye contact, trouble with back and forth conversations, to name a few. ASD is a spectrum, so its symptoms are very heterogeneous or varying. Folks on the spectrum might be like me. I have ASD 1, so I don't require many structured accommodations, but other autistic people might be nonverbal, require substantial support, or dependent on caregivers, and they'll be ASD 2 or 3. As the saying goes, if you met one autistic person, you've met one autistic person. We're all very different. It's also diagnosed behaviorally. There's no blood test or brain scan that can diagnose autism. Usually, a mental health professional needs to diagnose it through observation or discussing symptoms. Sensory symptoms, despite being widespread, wasn't even mentioned in the DSM, or the Diagnostic and Statistical Manual of Mental Disorders, until the fifth version that came out about 10 years ago. So there's still lots of research that needs to be done, and we'll delve into that here. ASD sensory symptoms can be divided into two broad categories, hyposensitivity and hypersensitivity. So hyposensitivity, hypo means less. So people who are hyposensitive are less sensitive to sensory stimuli. It'll usually manifest in sensory seeking behavior. When autistic people can't find the sensory stimulation they need, they'll go and find it. So that can mean staring at bright lights or becoming preoccupied with a certain sound. It could also mean stimming, which is a classic symptom of ASD. Stimming is basically fidgeting, but to a higher degree. Like everyone fidgets. They crack their knuckles or they collect their pens, but autistic people might spin or they might rock or flap their hands or pace back and forth. So you'll find that a lot of the behavior that you might associate with autism, like stimming, is actually rooted in their sensory experiences. Hypersensitivity is the opposite, and it means what you think it means. Hypersensitivity is an increased sensitivity to sensory stimuli. Hypersensitivity manifests in aversions. That could mean food aversions, so difficulty eating certain flavors or textures, or it can mean noise sensitivity. And that's why you see lots of autistic people wearing noise blocking headphones. Or it can mean being unable to tolerate certain textures of cloth or bright lights, etc. So there's so many ways researching autistic people's sensory symptoms can benefit outcomes. First, education. Some researchers has indicated changing the architecture in which autistic students learn could benefit the student. That could mean establishing physical barriers to minimize visual distractions or soundproofing rooms. Understanding sensory symptoms also has implications in healthcare. Autistic populations are far more likely to interact with the healthcare system. And you might think, oh, well, ASD is a social communication disorder. How does that work? But compared to the general population, autistic people are more likely to have epilepsy, gastrointestinal issues, sleep disorders. Autistic people, especially autistic children, are more likely to be affected by accidents, especially drowning. Mental health issues like anxiety and depression are especially prevalent in the autistic community. And autistic people are more likely to attempt suicide than the general population. So you get the point. Research into autistic experiences in healthcare system reveal how sensory issues can affect autistic people's care. Healthcare providers are often not educated on how to manage sensory symptoms, especially in emergency situations. And autistic people can experience sensory overload in unfamiliar situations like an emergency. Especially in with this medically vulnerable population, we need more research in how to improve healthcare outcomes for autistic people. Thirdly, research into sensory preferences empower autistic individuals to manage their symptoms themselves, whether it means being cognizant of their triggers or being aware of how to mitigate their sensory symptoms by using fidget devices, noise-canceling headphones, or strategies like exercise, which one meta-analysis showed to help with both sensory seeking and sensory sensitivity. More research into this field helps autistic people to become more independent. So our study was an exploratory study, trying to get more information on how sensory preferences might affect participants with higher autistic traits. We disseminated in a digital survey at Lake Washington High School in Washington State. Participants were between the ages of 14 and 18, and we had a total of 115 usable responses. Our survey was split into two parts, the AQ questionnaire and the sensory survey. So AQ stands for Autism Quotient, and it was originally a 50-question questionnaire developed by Simon Baron-Cohen and his team in 2001. We randomly took 10 questions from the 50-person questionnaire and included them in our survey. This is an example question. People often tell me that I keep going on and on about the same thing. Definitely agree, slightly disagree, and definitely disagree. If you slightly or definitely agreed, you'd score 1 point. If you slightly or definitely disagreed, you'd score 0. And that's basically how the entire survey is formatted. We selected 10 random questions from the survey and to determine how likely each participant had ASD. If you scored a 0, you would have a very low chance of having ASD, while if you scored a 10, you would be very likely to have ASD. The threshold score for the original test was 26 out of 50, so we adjusted the threshold to 6 out of 10 in our study. That means if a participant had a score of 6 or above, they were considered likely to be autistic. The second part of our survey was the sensory survey. There were 3 questions for visual, auditory, tactile, and olfactory preferences each. We excluded taste because of the variability in taste preferences across cultures. An example of a question would be, do you prefer to avoid or seek certain types of touch? For example, hugging and handshakes. So 1 would be strongly avoid, 2 would be somewhat avoid, 3 neutral, 4 somewhat seek, 5 strongly seek. If you could score a 1 to 5 for each question, and since there were 3 questions for each sensory modality, so like visual, tactile, auditory, olfactory, the minimum score was 3 for each sensory modality, which indicates an extreme hypersensitivity, and a maximum score was 15, which indicates extreme hyposensitivity. So our results. When I analyzed our data, I used 2 related metrics for measuring sensory preferences, a raw sensor score, which goes from 3 to 15 for each sensory modality, and a sensory extremeness score for each modality. The extremeness score was how far away a participant's raw score on a particular modality, like visual, differed from the average score on that modality. That quantifies how extreme their sensory preferences are, or how hypersensitive or how hyposensitive they are. And you'll see why I did that in a little bit. So for this graph, I took the average raw visual scores for each AQ score from 0 to 10 and plotted them on a graph. Notice how the graph trends slightly downward, so that indicates individuals with higher autistic traits are more hypersensitive to visual stimuli. And you'll see that there's a small correlation between AQ and the raw score, determined by the R-squared value, which can be between 0, which is no correlation, that's completely random data, and 1, which is a full correlation. And a correlation is 0.18, so pretty low. It means that the differences in AQ only account for 18% of the differences in sensory preferences. So, but if we consider the average visual extremeness scores for each AQ score from 0 to 10, it's a completely different story. The correlation is stronger with an R-squared value of 0.45. So what might be happening here? The raw score doesn't tell us the full story. Probably what's happening is that high AQ scores tend to have extreme sensory preferences, but they might be either very hypersensitive or very hyposensitive, and like they're canceling each other out. However, if we treat very low and high scores as the same thing, as we do on the right graph, we see a stronger correlation. And here's the rest of the data for raw scores. And what do you notice about their slopes? They're all negative, all of them. That means that participants with higher AQ scores, so more likely to be autistic, tend to be more hypersensitive than they are hyposensitive, so more likely to be uncomfortable with strong or unfamiliar sensory stimuli. The R-squared values for the auditory and olfactory graphs are the highest, so both around 0.4. So AQ scores predict auditory and olfactory hypersensitivity the best. So recap, higher AQ scores predicts hypersensitivity in all 4 sensory modalities, but predicts olfactory and auditory hypersensitivity the best. Now let's look at extremeness scores. What do you notice about their slopes? They're positive, all of them. That means the higher AQ predicts more extreme sensory preferences. Visual and olfactory extremeness had the highest correlation with AQ. So they had a higher R-squared values. So let's compare raw versus extremeness scores in regards to R-squared. Remember, R-squared quantifies how well the autism quotient, or AQ, predicts the sensory raw score or sensory extremeness score. Notably high scores are highlighted here. Note that the visual and auditory modalities have large discrepancies between their R-squared values. This is probably due to hypersensitive and hypersensitive participants canceling each other out when they're averaged in the raw score, like I talked about earlier. And that's why I used both raw score and extremeness score to get the larger picture. AQ predicted olfactory very well across both scores, and tactile is sort of just like really low from 0.0885 and 0.0734. And it looks like autistic traits don't predict tactile preferences as strongly as we measured in our survey. Now, our survey also asked participants to self-report their gender. We had 35 male respondents and 65 female respondents. Here, I've calculated each gender's average AQ, and notice that females have a higher average of 5.1 compared to 4.5. And I thought this was really interesting because there is no way that these results would be replicated with a higher sample size. It has been heavily documented that autism is much more common in males than females. This study by Hull and colleagues notes that if you could screen a representative population of men and women for autism, 3 men would receive a diagnosis for each woman. Well, if you tally up all the people who already have diagnosis, 4 men would be diagnosed for each woman. So why is my data this way? The reason is probably sampling bias. People who are more already diagnosed with autism or suspect that they have it probably responded to the survey at higher rates than the general population. Since we have almost double the number of female respondents than male respondents, that effect was probably further amplified. However, I found another interesting fact about our gender data. 11 respondents self-identify themselves as non-binary, which means they don't consider themselves a man or a woman. And their average AQ was a 7.0, significantly higher than male and female respondents. And another way to look at it would be the threshold score. Do you remember this graph I showed you? Remember that 6 out of 10 on the autism quotient questionnaire means that someone was very likely to be autistic. Well, 33.3% of males met that threshold, 44.6% females, and a whopping 81.8% of non-binary respondents. So why might this be? There aren't a lot of large-scale studies, but current research suggests that ASD is more prevalent in people who are gender non-conforming, so trans and non-binary people. More broadly, members of the lesbian, bisexual, gay, trans, and queer or LGBTQ community experience higher rates of autism as well. So, takeaways from our study. Higher AQ is moderately correlated with visual, auditory, and olfactory preferences, but not very correlated with tactile preferences as we measured it. For all modalities, people with higher AQ scores tended to be more hypersensitive to stimuli rather than hyposensitive. And across all modalities, people with higher AQ also just had more extreme preferences in general, whether they were hypersensitive or hyposensitive. In addition, we found that non-binary respondents had significantly higher AQ scores than participants with a binary gender. So, my study was exploratory. Where are further avenues for research on autistic sensory preferences? One would be examining how sensory preferences affect outcomes in specific settings, like educational or medical. Second would be examining other factors that affect sensory preferences. AQ scores, at its highest, accounted for less than half of the differences in sensory preferences. The other 50% could be due to culture, genetic, or a host of different factors. And thirdly, conducting larger studies on how ASD and the LGBTQ community intersect. Members of the LGBTQ community are not only more likely to have ASD, they're also more likely to have disabilities of all kinds. So why might that be? Thank you for watching. My name is Eunjae, and I hope you enjoyed my presentation.